Alright, so as you can see, this is our Wi-Fi car, Team Skynet. My name is Cliff Adams, and I'm going to be talking about how we got this to work. Here we can see our concept map, what we started with, of how we wanted everything to operate together. We started with a 12-volt battery here, and that would go through the voltage regulators into our control side of the circuit, where it would power the router, which would connect to one of our computers. It would also power an Arduino Mega, which would control all the ultrasonic sensors. It would also power the MyRio, which then used an Ethernet dongle connected to its USB port, which would then connect to the router and connect to the computer. And this was kind of the heart of the operation, was the Rio. The Arduino Mega we had to use because of the PWMs of the ultrasonic sensors, and later when we added a camera mount with servos that could move our camera around, it also needed PWMs to control those servos. Here's the camera that I'm speaking of. It also connected the USB hub to the MyRio. Its feed was then sent back via the router to the computer. On the other side, the e-stop we had to move on in between the relay, which controlled the motor drivers. The e-stop was an emergency stop button that would cut power to the vehicle for safety issues. It was a big red button on top, which you can see right here is the e-stop. Here's the camera mount servos up here. They also, like I said, needed to go to the Mega. So the motor drivers we had to use were saber-tooth motor drivers. They connected to 4 motors on each corner of the car. These motor drivers are able to have 2 channels, forward and reverse, and left and right. While wiring those up, we were able to run 2 wires from the Rio with 0 to 5 volts in order to control the steering of the car. So here's our parts that we ordered, our bill of materials. Here's the camera mount. We have links and prices for everything before we ordered it. Most of the stuff we ended up using as it was. I know the dongle, we had to order a new dongle because this one, the chipset wouldn't operate with the Rio. So we had to order a new one that we did eventually get to work. The voltage regulators ended up not getting ordered, but we also ended up not needing those, so that worked out just fine. The heat sinks also never got ordered. So this is our control panel here. You can see the camera feed comes in here. You can change it from live feed to standby. The mini joystick on the joystick controls the outputs of the Rio that go to the Mega, which then control the servo. These are the digital outputs that come out of the Rio. They're then read by the Mega. The Mega interprets those and then tells the servos which way to move. There's also a center button here, which I'll show here in just a second, that actually centers the camera back to its original position. We tried to make the camera able to see while you're driving, but unfortunately there's just not enough bandwidth to allow that to happen. It just causes too much lag in not only the proximity sensors but also in the steering, which then makes it run into things, which is kind of dangerous. So for safety, we just made it to where you can't put the car in drive while the camera feed is on. You have to turn it to standby, and then you can set it into drive. When it's in drive, it reads commands from the joystick. These are the outputs that go from the Rio to the motor drivers, and 2.5 volts is neutral for both the forward, reverse, and left-right channels. 5 volts would be full steam ahead, and 0 would be the opposite way. As you can see, the camera is kind of misleading right now, but the car would be moving if it's in drive, and it's moving along. So the e-stop also is on the car, and as soon as that's hit, it forces the car into park mode, and it won't be released until the e-stop is physically moved. So the proximity sensors, they were also kind of a challenge for Jesus to get working. As you can see here, each one's triggered individually. When it turns yellow, that means something is close. When it's close enough, you can see the avoidance stop kicks off and then forces the car into park mode, which holds these at left and right. We added a override that, as you could just see, it took the avoidance stop off temporarily while you held down the trigger button on the joystick, and that allowed you to move away from any objects that you might be near without having to get up and physically move the car yourself. Other than that, there's also a clear button which will then turn the avoidance stop off until it's triggered again. The battery monitor also, we used a voltage divider to monitor the battery on the car, and there is a low battery indicator here.
Okay guys, this is Jesus, and I'm going to talk to you guys about the schematic to the T-100. Right here is the battery, and this is where the router, the MyRio, the Arduino gets its power supply from. And the Arduino communicates with the MyRio through digital high signals. It will send a high signal if these ultrasonic sensors right here get triggered at a certain distance. And then the MyRio will send out a high signal to the Arduino to control the camera mount, the camera servos right here. And right over here we got the motor drivers with the motors on each side.
So it's Cliff again. Here you can see our car in action. We did have some trouble with the controls and lag. Like I said, we couldn't run the camera at the same time. There was just too much bandwidth. Sometimes too, the router just kind of gets interference and the car gets a little jumpy and glitchy. For the most part though, it's pretty responsive. And here's the operation of the joystick here. As you can see, when he pushes forward, it goes forward. You can kind of hear it in the background. When he goes back, it goes back. The control panel is there in the background. And we have one more clip here at the end. I'd like to thank everybody for tuning in and seeing the project. Hope you enjoy it.
Nice.